Hi, I'm Dr. Kim Klube, Publishing Manager for the Royal Astronomical Society's journals. Welcome to our celebration of 100 years of publishing geophysics. This started off in 1922 with a single paper, and now we publish around 600 papers a year in our journal Geophysical Journal International, papers by scientists from all over the world. I hope you enjoy these stories we have to tell. In today's story, we go back to the beginning of scientific publishing.
I'm Dr. Sue Bowler, and I edit the membership magazine of the Royal Astronomical Society, getting contributions from fellows in astronomy, but especially in geophysics. Well, we've seen that people very early on were wondering about the Earth, looking at the Earth, and publishing their ideas in books. And in 1660, seems quite a long time ago, an international group of scientists got together in London to form the Royal Society, the first learned society dedicated to science and the uses of science. And scientists would come to those meetings, or people interested in the Earth perhaps, or the skies, and share their ideas. And very soon, the Royal Society decided that it was important to share those ideas in print. So in 1665, they started what is the first journal dedicated to science. It's called Philosophical Transactions. And this was how men interested, and it was men, interested in the world around them, put their ideas down on paper for others to read and think about, and maybe criticize or suggest changes. This was the beginning of a scientific method where you build up ideas one brick at a time until you build up a whole new theory or a new understanding of the world around you. This is a fascinating book. I am really struck by the illustrations in it and the way that the author is taking things that he has observed. He's observed volcanoes. He's observed that they pour out fire and molten rock. And the author here is not just showing us images of volcanoes. He's trying to put together an idea of how they come to be. And he has this wonderful illustration showing rivers of fire under the earth connecting the volcanoes. So he's put together observations that the same thing happens at more than one volcano and deduced that they are in some way connected in the very mysterious interior of the earth. Now, of course, we know his ideas don't really make sense today, but they're a way of making sense of the world. They're saying, I think this could be why there are volcanoes in different places doing the same thing. And that's the start of scientific observation and scientific thinking, taking some data and saying, maybe this is why it is the way it is. Edwin Halley was an astronomer, but he was also, I suppose we would call him a polymath now. He was interested in weather, in mathematics, in the earth, magnetism, all sorts of things. We know his name because of the comet named after him. Now, Halley observed this comet in 1682, and he used the new mathematical methods of Isaac Newton, also published in the Royal Society, to calculate its orbit and predict that it would return, which it didn't do in his lifetime, but it has done ever since, most recently in 1986. Edwin Halley was really interested in the Earth, and he was interested in magnetism, the reason why compass needles point towards the North Pole-ish and allow us to find our way around. He was interested in this because navigation was a big problem in the 17th century. It was very difficult to know where you were. Halley talked a lot to sea captains, navigators, explorers, and in 1683, he published his ideas about magnetism in the Philosophical Transactions. And he used other people's data. He used sea captains' measurements of where their compasses pointed and how that was different from where they calculated the geographical North Pole to be. And so he knew at this time that this measurement, it's called the magnetic declination, was different in different places on the planet. And he also knew that it varied in time, because he found 5 occasions over a period of 100 years where people had measured that declination in London, in the same place, and it varied. And Halley got what is a strikingly modern model of the Earth's magnetic field from that. He said, Earth is one great magnet, having 4 mathematical poles or points of attraction. And as he studied it, he reasoned that it changed. It changed over time and it changed in places of the Earth. So he had this model of our magnetic field as if there's a bar magnet in the center, but also some moving magnetic poles. So he was predicting ideas about the changing magnetic field that we now rely on in our understanding of the Earth 350 years later. This is a wonderful map. This is Edmund Halley's map of the Atlantic Ocean that was published in 1701. And it's significant for a lot of reasons. The work that he did for this and the map itself was published in Philosophical Transactions of the Royal Society. And it came about as a result of 2 voyages Halley undertook as captain of the ship Paramour from 1698 through to 1700. And he communicated this map, the results, to the Royal Society 2 months after his second voyage finished. So what does it show? Well, you've got the North Atlantic, the South Atlantic, the icy seas at the bottom. Halley went right down almost to the tip of South America. They were long voyages. And he went there because, as well as being an astronomer, he was interested in navigation. And he knew from asking sea captains, explorers, navigators, that when you used a compass to point towards the north, it didn't always point in the same direction as you would deduce north from observations with a sextant, what we consider true north or geographical north. And he knew that it was different in different places. So he went to find out for himself. He wasn't somebody who would take anybody's word for it. He had to go and find out what it was like. So what this map shows in these long curving lines is places where magnetic north and true north are in exactly the same direction. That's the heavier line curving down the middle of the Atlantic. And each side, those lines on the map show where magnetic north is 1 degree or 5 degrees west of true north. And similarly, on the other side of the central line, lines where it's an equal amount different to the east. So this map is special in many ways. It's not directly a map of data, it's based on data. It's a statistical map. Halley used some really quite complicated mathematics based on the work of Isaac Newton to average between his data points and then put these maps in, these lines on the map in as an inference. So that's novel. It's the first time actually lines joining up where a measurement is equal have been used. We use them all over on weather maps now. You get isobars. Well, these isogones are the first time they have been used on a map, and they actually made it very practically useful for sailors and navigators later on to use this map to help them find out where they were on the sea. The idea of scientific publishing really caught on. It was very successful. And so did the idea of having a learned society dedicated to science. So societies such as the Royal Meteorological Society started, and in 1820, the Royal Astronomical Society. It didn't take long for the RAS to start publishing a specialist journal. It started with the memoirs of the RAS in 1822, and by 1827, the journal Monthly Notices started to be published. This was, in focus, an astronomical journal, quite specialized, but our fellows, a bit like Edwin Halley, had very broad interests. And so, through the years, a lot of papers on geophysics were published alongside the astronomical research. By the early years of the 20th century, the idea had begun to appear in the Royal Astronomical Society that we needed a separate specialist journal about geophysics. And in 1922, that is what the Society began to publish.
Hello, my name is Sean and I work in the library of the Royal Astronomical Society, and I'm showing you a huge book called Mundus Subterraneus, or in English, The Underground World. And this was written by a Jesuit scholar called Athanasius Kircher in 1665. Our copy dates from 1678. And it contains some spectacular diagrams, including this one, which shows a diagram of fiery interconnected channels inside the Earth.